So just like with the addition and subtraction methods, I want to explain all of the multiplication methods. And so we'll start with Pat's strategy here. And just for a lack of space, I'll start here with number 4. And what I want you to see is that Pat, unlike the standard algorithm, right, where you always start with the ones, they're thinking about this like Marcel did and like Donovan did with the partial sums and then partial differences, right? By starting with the largest place value. They're thinking about this like 20 plus 9 times 30 plus 4. Goodness, sorry, that's terrible. And I'm actually gonna try to color code a little bit. 20 let's see how this works. And so what I want you to see here is Pat's thinking about this as 20 times 30, right? And that's where we get this 600. 20, and this is I'm not gonna write that in there. I'm just gonna get 2. It's not big enough, not enough room there. And then we can see, then we have the 9 times the 30, right? To get the 270, 9 times the 30. And then we go back and do the other digits. Oh, not blue, red. So then we do 20 times 4 to get 80, right? 20 times 4. And then we do 9 times 4. 9 times 4 to get that 36. So we see where these 4 these 4 products come from. And that's why this is called the partial products, because we decompose the factors and we then multiply all of the pieces. And a great way to see this is with what's called an open array. I'm going to try and make it big so that way you can kind of see what's happening. If this is my 20 and my 9, and this is my 30 and my 4, sorry, wrong button. Right, we can add those. And then what we see then is we do 20 times 30. And that's where this 600 comes from. Right here. And then we do the 9 times the 30. And that's where this, sorry, I'll write it orange, this 270 comes from. And likewise with the 20 and the 4, right? 20 times 4, and then 9 times 4 gives us this 80. Oh, sorry, this should be red now. That bottom, right? The 20 times 4 is now 80, and then the 9 times 4 is the 36 for these last 2 pieces. Products again, right? This is why it's called partial products. We multiply these numbers by first decomposing them, breaking them up, and then multiplying each of the pieces. What I want you to see is then what we do is we add, right? This is the missing sign here in all of this is the addition, where we add up all of these pieces underneath. And we do that because here we can think about multiplication as area. And what you want to see is that we've broken up this area to show each of these pieces. And we do that, right? What is this property called? The strategy is called partial products, but why you are able to do that is because of the distributive property, right? We distribute each piece to each other piece And we can see that represented in this open array, right? Both, or if you like it as the binomial times the binomial, you may have heard that called FOIL, right? Maybe if you taken an algebra class, but I want to encourage you to eliminate FOIL from your vocab, right? The reason why FOIL is not helpful is because FOIL only applies to a binomial times a binomial. If we look here with what's going on with Pat's strategy, look at number 6. If we were to decompose these two factors, we would have 200 plus 10 plus 2, right? 212. And then we'd have 300 plus 10 plus 5, right, for 315. Now we can do the same thing with this open array. And sorry, this is going to get a little cramped. I should have made this one the big one. But we have what's called now a trinomial times a trinomial, right? 210 and 2. And then times, well, it doesn't matter which way you go. I know I put the green ones on the top. 300 plus 10 plus 5. And now the same thing. 200 times the 300 gives us our 600 again. Oh, sorry, not 600. 200 times 300 is 60,000. Right? And so what Pat would do, if we look at number 3, right, that he would just start, or they would just start writing all the numbers down in this space right here. But which is fine, right? It just becomes this long laundry list. But I like the open array method just to kind of organize each of the pieces. And it also helps you to keep track of what you're multiplying, when, and how. So I'm going to let you finish that open array and compare it to what you wrote underneath of number 6 with Pat's strategy. So I want to show this as another representation. This partial products manipulative only lets you go up to 50 by 50. So I figured I would do the 29 times 34. And so again, you can see this as 20. If you would like, write 30 times 4 at the top and 20. Sorry, did I say just times? Sorry. 30 plus 4 to make 34, 20 plus 9 to make 29. And here you can see that same idea. 20 times 30 is 600. So there's 600 little squares here. You can count them all. 20 times 4 is this 80 right here, right? There's 4 groups of 20. 9 times 30, there's 270 there, and then this 36, 9 times 4. So you can see all of these different pieces and how they make up this whole array, or the total area for this 29 by 34.